The MacGyver spirit of Ukraine. To MacGyver something means to make or repair a piece of equipment with whatever materials are at hand. Duct tape, scrap metal, and a pair of crossed fingers are the usual signs that something has been MacGyvered. And while this may lead some to think that improvised and cheap weapons are ineffective or of poor quality, the war in Ukraine is a blatant example of their effectiveness. Most of this technology is made possible by donations from ordinary citizens and supporters of the cause. As the people of Ukraine rally around their soldiers, old cars, trucks, wagons, and whatever supplies can be scavenged up are shipped to the front line. Although it's unclear to what extent many of the older cars are impacting the war, one thing is sure: drone technology is pestering and slowing down the Russian advance. One thing that was repeatedly brought up and requested by Ukrainian soldiers was the need for quality maps. Using cheap drones has made it possible for many soldiers to see their surroundings clearer and gain meaningful insight into enemy movement and troop location. Before the use of drones, many Ukrainian soldiers were stuck with Soviet handmade maps from the 1980s. But this all changed with Alexei Savchenko's Army SOS. The Army SOS is a non-governmental organization tasked with supplying the Ukraine Army with supplies and sometimes recruits. Savchenko remembers how service members would say to him, "Where there used to be a field is now a village or an apartment building." Savchenko helped coordinate a tech solution by using a company in Kyiv to install satellite maps and military data on tablets and smartphones. With so many people sending supplies to Ukraine, here are some ways the military is transforming cheap materials into useful military technology. DJI Mavic Quadcopter. The $4,000 Mavic Quadcopter is being used with devastating effect by both the Russians and Ukrainians in the Ukraine war. While some are used to map out the landscape, others are outfitted with small explosives and flown into more expensive machinery. The drones are mainly off-the-shelf models which are bought online for hobby use. They're being used to surveil Russian troops, find the best point of attack, and even drop small explosives directly onto the enemy. This has been made possible with donations of civilians and foreign organizations, resulting in the Ukrainian army having more than 6,000 commercial drones. Innovations used to make the drones battle-worthy include 3D printing, which has been used to develop attachable parts to drop grenades or small bombs on targets. Drones have improved the efficiency of artillery, as they can replace soldiers for reconnaissance missions and are difficult to detect and destroy. The use of drones has also had a positive impact on the morale of Ukrainian troops. Photos and videos are posted online to showcase the clever ways in which the drones are used, and this has given the soldiers a sense of pride. It has also instilled fear into the Russian troops, making them aware that they're being watched. Overall, the use of drones has been a great success for the Ukrainian army. It's enabled them to perform surveillance, reconnaissance, and even offensive operations, proving to be a valuable asset in the war against Russia. Kropiva software. While soldiers are clamoring for more drones, the military is furiously trying to stay ahead of its enemy counterparts in the software used by the drone. The Ukraine military has expertly found a way to convert an Android tablet, which costs just $150, into an automated precision guidance system. Kropiva, a software developed by Alexei Savchenko and a group of software developers in Kyiv, has had a significant positive impact on the Ukrainian war. Kropiva turns an Android-based tablet into a basic unit of an automated precision guidance system. It can acquire and transmit coordinates for correcting artillery fire from a drone or radar, and then calculate the distance to targets and direct shots of each type of artillery used in the Ukrainian military. This has enabled troops to see their surroundings more clearly and to correct artillery more quickly and accurately. Kropiva has also saved lives in other ways. It can measure distances, enter coordinates, and guide troops through all types of terrain, enabling them to detect and avoid minefields. In addition, Kropiva has allowed troops to remain in contact with the command centers, even when web access is not available. The calculations are made and transmitted within seconds, which can be the difference between life and death in a war situation. Overall, Kropiva has helped to transform the Ukrainian military from an underdog to a powerful force of resistance. It's enabled troops to see their surroundings more clearly, to correct artillery more quickly and accurately, to detect and avoid minefields, and to remain in contact with command centers even when web access is not available. These factors have helped the Ukrainian military gain a significant advantage in the war and have likely saved countless lives. DIY all-terrain buggies. The increasing use of cheap do-it-yourself vehicles by the Ukrainian army has had a significant impact on the war effort and has been an important factor in the conflict. These vehicles, which are often built from older models with outdated engines, have been used to great effect in harassing Russian forces and providing support to Ukrainian soldiers. Coming under a $2,000 price tag, the widespread introduction of these low-cost vehicles have enabled Ukrainian forces to be more mobile and allowed them to launch surprise attacks against Russian forces, who are often unprepared for the suddenness of the attacks. The vehicles being made are the products of Ukrainian citizens in garages across the country. People such as Sergei Bondarenko, a local leader of the territorial defense Yevgeny, codenamed Badger, and Vitaly Brizgalov have tasked themselves with making all-terrain military buggies for the Ukrainian army. Bondarenko has been fighting against the Russians since 2014 and has built a heavy machine gun which can hit targets at a distance of 6,000 meters. Yevgeny has transformed a 30-year-old all-terrain Mercedes truck by placing a homemade multiple rocket launcher system on it. The rocket launcher system is made from 4 tubes of a destroyed Russian Grad missile system. Vitaly Brizgalov has been making all-terrain military buggies for the army in his small garage. These buggies are made from antique Lada engines and can be customized with the addition of different weapons. The vehicles are being made to help the Ukrainian army combat the Russians and have become a symbol of the mobilization of an entire country. This do-it-yourself approach is proving to be a valuable addition to the Ukraine war effort. HARM missiles on Soviet fighter jets. Ukraine's military has found a way to attach HARM missiles on their Soviet MiG-29 and Su-27 fighter jets to weaken Russia's air defense capabilities. This match between the United States missile and the Soviets' fighter jet was previously thought impossible before the war in Ukraine. The integration of the missile on the MiG-29 and Su-27 fighters involves a lot of work in the avionics and electrical systems. To make the missile work, a simple tablet is linked to the missile to perform the targeting, possibly through the HARM's built-in sensor mode. A video released by the Ukrainian Air Force provided some details about the integration, but proved to be much less elaborate than expected. Somehow, the Ukrainians have figured out the impossible with a few relatively simple modifications. The missile appears to have been loaded directly on the APU-470 missile launchers used by both jets. As such, the Ukrainian military has been able to increase its own defensive capabilities while gaining a tactical advantage over Russian aviation. The MacGyver spirit of the Ukrainian people is truly remarkable. Against all odds, they've managed to create effective weapons from whatever supplies are available to them. Through their resourcefulness and ingenuity, they've been able to fight back against the Russian invasion with a fraction of the cost of the technology available to their enemies. It's a testament to the resilience and courage of the Ukrainian people that they've been able to use whatever materials are on hand to create such powerful weapons and to fight for their freedom. The MacGyver spirit of the Ukrainian people will serve as an example to others around the world that with a bit of creativity and determination, anything is possible. What weapons are being used in Ukraine? Russia's invasion of Ukraine brought the world's eyes to the capabilities of modern warfare. With missiles, tanks, and exotic types of bombs, the landscape for soldiers appears to be more dangerous than ever. The weapons used by both Ukraine and Russia are impressive in their capabilities and equally terrifying in their destruction. However, the destructiveness of the conflict cannot be entirely attributed to new weapons, as some of the most deadly events thus far have been the product of older technology. The cluster bomb, for example, was widely used in World War II by the Germans. Sprengbombe Dickwandig 2 kg, or the German SD-2, was a cluster bomb developed to attack both military and civilian targets. Likewise, Russia has been accused of using cluster bombs extensively to target populated areas and destroy vehicles. To date, there have been over 689 civilian casualties from Russia's use of the cluster bomb. This is not to say that newer technology is not as destructive, far from it. Ukraine's use of the Bayraktar TB2 drone to destroy command posts, military vehicles, and air defense systems is just one example of new technology inflicting large-scale destruction. These weapons, some old and some new, are examples of the most dangerous weapons available for use today. Cluster bomb. Although the cluster bomb is a generalized term with many variations, at its core, it's made up of a hollow shell with thousands of smaller bombs inside. In the Ukraine war, Russia has outfitted their cluster bombs with small parachutes to slow the bomblet's descent, which allows fighter pilots to carry out low-altitude attacks. The cluster bomb has been banned since 2010 under the Convention on Cluster Munitions. Following reports by the Cluster Munitions Coalition of Russia's use of the weapon, many countries have come out to condemn their actions. On March 2nd, Linda Thomas-Greenfield, who's the United States' ambassador to the United Nations, issued this statement, quote, "We've seen videos of Russian forces moving exceptionally lethal weaponry into Ukraine, which has no place on the battlefield. That includes cluster munitions and vacuum bombs, which are banned under the Geneva Conventions," end quote. The cluster bomb's appearance in Ukraine is especially alarming because Russia is using it to target highly populated areas. This results in many civilian casualties and destruction to infrastructure in Ukraine. More disheartening still, a study by Handicap and Inclusion, which is a French charity dedicated to disaster relief, found that only up to 40% of the small bombs detonate on impact. This means after a cluster bomb is dropped, as many as 60% of the bomblets are dangerously scattered around the area, ready to explode at any time. Bayraktar TB2 drone. The development of drone warfare has forever changed the landscape of war. No longer will pilots risk their lives in the cockpit of a fighter plane, dogfighting in the skies above the battlefield. Now, unmanned drones can be controlled by someone in an office building thousands of miles away. The Ukraine military has utilized this technology to devastating effect in their struggle against Russian forces. 12 of the Bayraktar TB2 drones were purchased by the Ukrainian military from Turkey in 2019, and now they're being put to the test. When the Russian military was massing in Crimea near Ukraine's border, it was the TB2 drone that carried out the first reconnaissance mission in an active conflict zone. Then, the drone was later used to destroy a Russian artillery position that was bombarding Ukrainian troops. With a blended wing body design and an inverted V tail structure, the drone is capable of staying at a medium altitude for long durations. A variable pitch two-blade propeller is mounted between the tail booms and produces enough thrust to propel the machine 224 kilometers an hour through the sky. More impressive than this, the drone can also be outfitted with 4 laser-guided bombs that are capable of carrying out devastating stealth attacks. SIG MCX semi-automatic rifle. Used by Ukrainian Special Forces, the SIG MCX semi-automatic rifle was first released at the SHOT Show in 2015. This weapon is highly customizable and comes in many variations. However, from photos of the weapon in Ukraine, it appears that the 11.5-inch barrel and suppressor handguards version is being used. The taper of the barrel's profile allows both muzzle devices and sound suppressors to be directly threaded onto the weapon without the need for washers. This allows the weapon's barrel to be changed in just a few seconds to virtually any length and caliber. Regardless, all weapons of the SIG MCX series utilize a short-stroke gas piston system, which dramatically reduces recoil and improves the durability. There is a reason this weapon was chosen by the Ukrainian Special Forces to protect their country. It's so quiet with the suppressor that shot timers have to be placed at the ejection port to pick up any sound. In addition to this, the weapon is capable of firing 800 rounds a minute at targets over 500 meters away. The firepower of this rifle, in tandem with its virtually silent nature, makes it an incomprehensible problem for any opposition. The world is so used to battlefields being filled with a sonic landscape full of explosions and rapid gunfire, but now it appears the most dangerous new weapons will favor stealth. After all, even more frightening than the sound of a machine gun is to not be able to locate where 800 rounds a minute are coming from. NLAW, anti-tank weapon. Now synonymous with Ukraine's stubborn resistance to the Russian advance, these British anti-tank weapons are responsible for 30 to 40% of Russia's tank losses. To date, Russia has lost roughly 1,500 tanks in Ukraine and has been forced to drag out Soviet-era machines to keep the pressure on while advancing. The NLAW is the perfect light anti-tank weapon at a maximum weight of 28 pounds and with an effective range of between 20 to 600 meters. These weapons can be fired in close proximity to other people and buildings because of their soft launch system, which allows the missile to be fired at a reduced speed and without an explosion before rocketing off towards its target. After being launched, the missile uses magnetic sensors to set off a proximity fuse before contacting its target. What this means is that the missile will detonate some distance before making contact and cause much more damage. Proximity fuses are believed to be 5 to 10 times more lethal than fuses that detonate upon impact. Further, this weapon is only $30,000 to $40,000 in comparison to its counterpart, the Javelin, which is $176,000. But if the great price and impressive specs are not a testament to the NLAW's effectiveness, then look no further than the smoldering ruins of Russian tanks alongside Ukrainian roadsides. T-90 Russian tank. The tank is an iconic sight on the battlefield, whether it's providing cover for advancing infantry or shelling enemy positions. The versatility of these machines cement their place in modern military operations. Russia counts the new T-90 tanks as among its best battle tanks and has relied on their presence to push into Ukraine. Only 3 crew members are needed to operate the 48-ton tank, which relies on its V92S diesel engine to get it moving at up to speeds of 60 kilometers an hour. Further, it comes equipped with a 2A46M 125mm smoothbore tank gun and a 12.7mm Cord heavy machine gun. The T-90 tank, while impressive in its capabilities, is over 30 years old and very weak to anti-tank weapons. As such, Russia has had to develop Arena, a modern defense system aimed at protecting the T-90 tanks from anti-tank missiles. Arena has not yet made an appearance in the 2022 Russian invasion of Ukraine, leaving us only to guess at how effective these tanks would be with their proper support systems. Instead, the T-90s have been outfitted with steel grills at the top of the turret in a desperate measure to fortify against the constant missile attacks. So far, there have been 31 confirmed T-90 tanks lost by Russia. Nevertheless, the speed and firing capabilities on these tanks makes them one of the war's most dangerous weapons. The war in Ukraine has cast a light on the capabilities of modern weapons, as well as reminded everyone that cruder developments such as cluster bombs still command a place on the battlefield. It's a strange study to observe how new weapons are becoming lighter, quieter, and more precise, while at the same time the battlefield is increasingly affecting non-combatants. Drones are capable of carrying out precise targeting missions, and yet cluster bombs are still being used to wreak havoc on populated areas. In looking at the most dangerous weapons of the Ukraine war, it becomes clear that, in some ways, we are all affected by this era's military technology, either being protected or destroyed by it. NATO, Leopard, Abrams, and Challenger tanks in Ukraine. Ukrainian President Volodymyr Zelensky has long asked his allies for an injection of fresh tanks to supplement his existing fleet of old T-72s. His pleas have now finally been answered by NATO members, with Germany offering 14 Leopard 2A6s, America pledging 31 M1A2 Abrams, and the UK promising 14 Challenger 2s. But which one of these tanks is the best? Beginning its career in the German Army in 2001, the Leopard 2A6, an advanced version of the Leopard 2 originally released in 1979, is 7.7 meters long, 3.7 meters wide, 3 meters high, and weighs 62 tons. The Leopard has seen action in numerous countries, including Austria, Canada, Chile, Denmark, Finland, Greece, Norway, Poland, Portugal, Singapore, Switzerland, Sweden, Spain, and Turkey. Next, developed from 1988, the American M1A2 Abrams is an improved variant of the M1A1 and is 7.92 meters long, 3.65 meters wide, 2.8 meters high, and weighs 63 tons. It's been exported to both Saudi Arabia and Kuwait. Finally, an extensively redesigned version of the Challenger 1 and the most modern tank of all, the British Challenger 2, entered the ranks of the British Army in June 1998 and is a bit longer at 8.3 meters, while having a width of 3.5 meters, a height of 2.4 meters, and a weight of 62.5 tons. Aside from the UK, the Challenger 2 is only served with Oman. The Leopard 2A6 can be distinguished by its RH 120mm L55 smoothbore gun. Using kinetic energy ammunition such as DM-53 and with a maximum ammo capacity of 42 rounds, the Leopard can fire at a range of up to 5,000 meters. But it can acquire targets up to 9,900 meters thanks to its laser rangefinder and thermal imager, enabling the gunner to engage targets in all weather conditions. Accuracy is provided by a dual magnification stabilized EMES-15 sight linked to a fire control computer which precisely calculates the angle of sight and lateral angular lead of the smoothbore gun. Close support fire comes from a pair of 7.62mm Rheinmetall MG3 machine guns, one on a coaxial mount and the other on an anti-aircraft mount, while smoke grenade dischargers are situated on either side of the turret. The M1A2 Abrams is fitted with one 120mm smoothbore M256 cannon, which can shoot a wide array of ammunition, including the armor-piercing M829 APF SDST, as well as the M380 Heat MPT, which stands for High Explosive Anti-Tank Multi-Purpose Tracer. To the right of the smoothbore can be found a 7.62mm M240 machine gun, while the commander station features a standard 12.7mm Browning M2 HB machine gun. On either side of the turret is an L8A1 6-barreled smoke grenade discharger, but a smokescreen can also be produced via an engine-operated system. For aiming, the Abrams has a 2-axis Raytheon GPS LOS, or Gunner's Primary Sight line of sight, which works alongside a commander's Independent Thermal Viewer, or CITV. This hunter-killer combination is incredibly lethal, for if the commander suddenly identifies an enemy, he can, with the press of a button, change the gunner's current sight so it shows the new target. The Challenger 2 is equipped with an RO Defense 120mm rifle tank gun that has a thermal sleeve, fume extractor, and muzzle reference system. It's complemented by an ATK Gun Systems Company 7.62mm chain gun mounted left and another placed at the load hatch. Like the other two, it also has smoke grenade dischargers, namely 2 banks of 5.66mm Thales FAV systems that cover the forward arc of the unit, and like the Leopard, it can also lay down a smokescreen by injecting diesel fuel into the exhaust outlets of the engine. For precision, the Challenger has a laser finder, thermal imager, and also employs the same hunter-killer system as the Abrams, with the commander's roof-mounted sight giving 360-degree visibility without the need to rotate the head. And there's also an extra thermal imager that's only used for surveillance purposes. In terms of weaponry, all 3 tanks are equally matched, with no clear leader. The hull of all Leopard 2s have standard-spaced multi-layer armor, but what makes the Leopard 2A6 different from its predecessors is the improved armor over the frontal arc and in front of the turret, which provides advanced protection against kinetic and chemical energy attacks. In addition, spall liners, which prevent internal damage caused by direct enemy hits as well as small fragments from flying around inside the vehicle, have been lined in the turret interior. The M1A2 Abrams also possesses advanced armor, which can effectively lessen the impact of anti-tank guided missiles, or ATGMS, and rocket-propelled grenades, or RPGs. It's also notable for the depleted uranium composite grafted into its armor, the heaviest naturally occurring element, which is due to extremely high density, and it's prized for its deflective qualities. Lastly, the Challenger 2 has the new Chobham 2nd Generation Dorchester armor, a similar type of shielding used by the Abrams, which can effectively resist the penetrative power of anti-tank missiles. While all 3 have state-of-the-art armor, the bulky Challenger has the edge over its opponents here. Add to this, the Abrams tanks specifically being sent to Ukraine have been stripped of their depleted uranium because of a U.S. federal policy banning the export of classified armor packages, significantly weakening the unit. The Leopard 2A6 is powered by a 1,500 horsepower MTU MB873 diesel engine and is installed with a Rank HSWL 354 gear and brake system. This means it has a top speed of 72 km per hour and a combat range of 500 kilometers. The propulsion system of the M1A2 Abrams is a full-up power pack, which incorporates a single Honeywell AGT-1500 gas turbine engine, which uses jet propellant fuel, although it can run on certain grades of diesel fuel. It has a top speed of 68 kilometers per hour and a maximum range of 425 kilometers. The Challenger 2 has a 1,200 horsepower 12-cylinder Perkins Caterpillar CV12 diesel engine connected to a David Brown TN54 gearbox with 6 forward and 2 reverse gears, in addition to a hydraulic track tensioner, which uses hydraulic pressure to maintain optimum levels of track tension. Its top speed is only 56 kilometers per hour, and its max range is 450 kilometers. Overall, the Leopard is the fastest of all and can operate for the longest time. The Abrams is a mid-performer, and the Challenger is the slowest. The Leopard 2A6 has a land navigation system with a GPS and inertial navigation software, as well as fire and explosion detection system inside the crew compartment. It also boasts an NBC protector system, which via tank interior sealing and air filtration safeguards it from nuclear, biological, and chemical assaults. Extra visibility is provided via infrared night vision and a TV camera strapped to the rear. The M1A2 Abrams is equipped with many of the same accessories, but it also has some of its own, such as the Intervehicular Information System, or IVIS, which shows where the tank is in relation to other friendly units, as well as being able to broadcast and receive information about enemy positions. The Challenger 2 also comes with virtually the same capabilities as the other two, but is unique for its environmental control system, which provides heating and cooling for the crew compartment. All 3 tanks have 4 crew members, a commander, a driver, a gunner, and a loader. On balance, then, there's no obvious forerunner in this department. In terms of technical prowess, there appears to be no obvious frontrunner between the Leopard 2A6, M1A2 Abrams, and Challenger 2. For while the Leopard is the zippiest but least protected, the Challenger is the best shielded and the slowest, with the Abrams somewhere in the middle. Therefore, looking to other more practical factors may prove helpful. Historically, the Challenger 2 has a strong record, for according to the British Army, it's undefeated, not a single unit having ever been destroyed on the battlefields of Kosovo or Iraq, where it is mainly served. And a previous version also claims the longest distance tank kill ever recorded at 4.8 kilometers during the 1991 Gulf War. But as its name suggests, it's difficult to train new operators. Next, although the Abrams are a world-class specimen, they are the most expensive at $9 million each, and are run on less available jet fuel, where the other two are run on diesel. Furthermore, even US officials have admitted they are hard to maintain and even harder to master. And so, it's the Leopard that must take the prize, because as well as being the most maneuverable, its enormous user base means it has the most readily available parts, and since it was originally designed to be operated by conscripted soldiers, it is the simplest of all the tanks to operate.
World War II guns being used in Ukraine. Relics fighting in the modern war. One could say that war never ends. For some weapons, their uses also seem to never end. Firearms produced for World War II can still be seen in today's front lines, still on par with their modern counterparts. Some of these are century-old designs, constructed for completely different warfare and conditions, yet pulled from their racks and still serving their main purposes. It's not unique, however, only to contemporary battles, campaigns, and operations to utilize old equipment. World War I saw usage of designs 40 or 50 years old. As it was anachronistic to use single-shot bolt-action rifles in World War I, it was the same as using multi-turreted tanks of the interwar period in World War II. There were instances on the battlefield where soldiers with old, worn-out assault rifles like the MP-44 were next to rocket-propelled anti-tank launchers. After World War II ended, there was simply huge stocks of various weaponry remaining. Rifles, submachine guns, anti-tank launchers, pistols, grenades, mines, bombs, all the weapons that were massively produced had to be put to storage. They wouldn't need to wait long for reuse though. The Korean War broke out in 1950, a mere 5 years after the end of World War II, only to be fully utilized again on all sides, along with the more modern ones. Later wars were no exception. During the second half of the 20th century, many wars were fought with a similar mix of World War II weapons and contemporary designs. As the technology progressed, however, so did these outdated and worn-out weapons become less visible in the ranks. Proliferation of assault rifles like the AK-47 made submachine guns and old rifles be completely pushed aside and practically useless in comparison. However, it didn't mean that those weapons would completely die away. Stocks were and still are kept. The world's superpowers still keep their old weapon stocks, for the second-line troops and as a reserve. Thousands of rifles of all calibers and types are stored away, a legacy of the Cold War arms race. After the political turmoil of Euromaidan protests in February of 2014, a war broke out in Donbass. In the twist of events, the understaffed Ukrainian army launched a so-called anti-terrorist operation in eastern Ukraine. Opposing them were the local militias supported overtly and covertly by the Russian Federation. Their initial equipment and weapons would range from helmets and baseball bats, but would be upgraded to include modern rifles, tanks, artillery rockets, and rocket launchers. One antique weapon would return to service on both sides early on, the late 19th century Mosin Nagant rifle, carried and used in Donbass by the pro-Russian separatist forces. This rifle was designed from 1882 to 1891, adopted in service in the Russian Empire, and saw service in many wars up to present day. It's a bolt-action, 5-shot internal magazine-fed rifle, chambering 7.62 by 54mm cartridges. Usually fed by a stripper clip, it has a good range and accuracy. It was made in many variants, including carbines and sniper rifles. It served well through World War I and World War II, used by all sides on the Eastern Front. It's a crude and durable weapon, capable of dealing an impressive amount of damage over long distances. It was this rifle that had served one of the most renowned World War II Soviet snipers, Vasily Zaitsev, a man credited with over 225 enemy kills. He was using a Mosin Nagant M1891 rifle, fitted with a PU scope. The Mosin Nagant was produced in over 37 million copies and served many armies. Even with the advancement of sniper rifles and other infantry weapons, this rifle is still a potent and dangerous adversary. Another interesting weapon, slightly younger than the Mosin Nagant, is the historic Maxim machine gun. The PM M1910 is a water-cooled medium machine gun, chambering the same 7.62 by 54mm cartridge, belt-fed. It has a rate of fire of some 600 rounds per minute, featuring a metal shield with a two-wheeled carriage. It was used extensively in both world wars. During its lifetime, it was modernized several times over, improving ease of use and performance in the field. It was common to see Soviet infantry advancing while being covered by Maxim gunfire. One of the modernizations saw a change to the water cooler cap, making it bigger to allow the option of adding snow as a quick coolant. The Ukrainian Ministry of Defense took advantage of the tens of thousands of these machine guns in their storage. In 2016, they were officially adopted into the armed forces and saw use in the war in Donbass. With the Russian invasion in 2022, these machine guns were more visible, being distributed to the territorial defense of Ukraine as well. Even though the Maxim gun cannot compete with modern medium machine guns like the PKM, it's still deadly and potent, capable of providing steady and constant volleys of fire over large distances. The submachine guns were seeing their full potential during World War II. Close combat inside Stalingrad was one of the major showcases of how short weapons with a good rate of fire and large ammo count could make a difference over the cumbersome long rifles. There were entire Soviet units which, when crossing into Stalingrad, would change their rifles for submachine guns. That would increase their firepower drastically and give them a fighting edge in the battle where buildings were fought over several times in a day. The PPSH-41, the most produced submachine gun of World War II, is a magazine-fed stamped steel weapon designed to be simple, cheap, and effective. It saw extensive use in the Soviet Army and in some conflicts after World War II. It can be fed with a stick magazine of 35 rounds or a drum magazine, which has a capacity of 71 rounds. It uses 7.62 by 25mm Tokarev cartridges. It was so effective and efficient that the captured firearms were enviously kept by the German soldiers. Due to the high rate of fire and large ammo capacity, it could produce fire suppressions and superiority in shorter ranges. The PPSH-41 would see extended service in the Korean and U.S.-Vietnam War. Other smaller conflicts would also see this weapon utilized. Many warehouses of the Eastern Bloc still have them, oiled and stored, should the situation arise. When the separatist militias in eastern Ukraine started to arm themselves, one could spot PPSH-41s among the soldiers. Either for propaganda purposes or for actual combat, this weapon still shines, 80 years after being introduced into the service. It's disputable how efficient this weapon can be nowadays. The previous common ranges for urban combat of only a couple dozen meters between troops in World War II have been largely replaced by a ranged combat of up to 300 meters in modern warfare. Assault rifles have mostly pushed out submachine guns, having stronger, more accurate, and deadly calibers. Additionally, assault rifles have so proliferated that it's now much easier to obtain one than an out-of-date submachine gun. Nevertheless, it doesn't mean that World War II submachine guns are not needed anymore. On the contrary, the younger brother of the PPSH-41, another submachine gun created by Alexei Sodayev in 1943, also saw service in Donbass. This submachine gun, named the PPS, was designed to provide simple and effective personal defense weapons for gun and vehicle crews, reconnaissance and support units. It used the same 7.62 by 25mm Tokarev cartridge as the PPSH-41 in a 35-round detachable box magazine. This weapon was crude, easy to produce, and was produced in millions of copies. Its advantage over the PPSH-41 was its foldable stock, which made it easier to use in cramped compartments of vehicles, as well as trench warfare. Although it didn't fully replace the PPSH-41, but rather complemented it, it would see service in the later wars and conflicts, just like its older brother, as it was more reliable, had a pistol grip, and generally it was easier to use. Overall, it was a practical, functional, and cost-effective weapon. Some separatist forces in eastern Ukraine manned the barricades in Donbass, although the actual use and efficiency is doubtful, given ranges at which combat is taking place and the general advantage of assault rifles and other modern weapons. Both of these weapons would use the aforementioned 7.62 by 25mm Tokarev cartridge. This cartridge is rather easy to obtain, as even the popular and mass-produced Tula Tokarev 33 also uses it. This pistol is commonly known as the TT, or simply Tokarev. It was designed in 1930 by Fedor Tokarev as a service pistol to replace by that time the old Nagant M1895 revolver, but it turned out to be a supplement to the Nagant rather than its obvious successor. The Tokarev has an 8-round detachable magazine, simple and reliable mechanisms and design. It fires quite powerful cartridges, which in turn has a flat trajectory and increased penetration capabilities. The gun is renowned for its reliability and had served in many wars after its production ended in 1955. It's not surprising that it was one of the first guns to show up after the conflict broke out in Ukraine. Pistols were not that hard to obtain, and ammunition was readily available. Members on all sides are using it, making its war record continuing well into the 21st century. However, what has been mentioned have been more or less typical military firearms. Something extraordinary also showed up in this conflict: the World War II anti-tank rifles of the Soviet design. Anti-tank rifles were the product of the First World War, or to be more precise, as a countermeasure for the introduction of Allied tanks. They were big, cumbersome rifles designed to fire a large bullet and penetrate the armor of the tanks. Many European nations continued to build them into the interwar period. The Soviet Union had 2 rifles at their disposal. One of them, the PTRD-41, was hastily constructed in 1941 to fill in shortages and provide Soviet infantry with some sort of defense against the tanks. It was a single-shot rifle firing a 14.5 by 114mm cartridge. This cartridge was originally developed for the PTRD-41 and PTRS anti-tank rifles, but it's still being used up until this day in numerous roles. Back in 1941, it was more than capable of defeating the side armor of lighter German tanks, self-propelled guns, and half-tracks in the early stages of the German invasion. Moreover, it could potentially tear apart tank tracks and damage tank optics and other equipment. Used against enemy personnel, it was also very potent, as the rifle could deal significant damage to people, as well as soft-skinned vehicles and buildings. After the end of World War II, the rifles were phased out and used in limited amounts in several later conflicts. The introduction of RPG-2 and later anti-tank rocket launchers made this type of weapon obsolete. It was too big, too heavy, made too much noise, and other vehicles and weapons could fire the same cartridge in bigger and more accurate salvos. But its story didn't end there. In Donbass, there were instances, especially early in the war, where militia members would use this weapon against Ukrainian troops and equipment. This was despite the fact that the rifle itself is some 80 years old. It is capable of penetrating or seriously damaging armored personnel carriers and other lightly armored vehicles. Furthermore, the PTR-D41 was also used in sniping activities. With its large round, a whole 1 kilometer of range, and penetration capabilities, this weapon could annihilate enemy dugouts, bunkers, control posts, and entrenchments. As a matter of fact, some are equipped with the thermal scope, muzzle suppressor, and a rail mount, making it a formidable anti-material rifle. With such a long range and devastating power, it had proved to be a good weapon even by today's standards. On the other hand, one disadvantage that the rifle has is that it's a single-shot weapon. The next 1941 anti-tank rifle was the PTRS-41. While the PTR-D41 was developed by Vasily Dektyarov, the second one was made by Sergei Simonov. The main difference was that Simonov's rifle was a semi-automatic one with a magazine capacity of 5 rounds. This rifle was used with the same pattern and same success as its PTR-D41 precursor. The prime targets were lightly armored vehicles and tanks, personnel, transport vehicles, and fortifications. However, during the Ukrainian war, this rifle had found yet another purpose, fighting against low-flying helicopters or drones. Some have even been pictured or filmed fired from the back of a supporting soldier, or even with the shooter standing up, shoulder firing. Even though the rifle itself is some 20 kilograms, the shooter was somehow capable of firing it from the shoulder. Another dreaded World War II weapon was the Dektarov machine gun, or DP-27. This weapon would have used the same 7.62 by 54 mm cartridge as the Maxim gun, but weighed less and was easier to move around. Almost 800,000 have been produced, and it served in numerous conflicts, both in the 20th and 21st centuries. The Dektarov machine gun itself was quite reliable, which was not the case for its disc-shaped magazines. The gun would consequently be given nicknames such as the record player, due to the shape of the magazine resembling gramophone players. Called into the service of the Ukrainian Armed Forces, it was seen on the outskirts of Kyiv, among the territorial defense members manning checkpoints. After almost 100 years of service, it is striking that such a weapon can still find its use in modern conflicts. The crudeness and reliability of World War II designs made the weapons last incredibly long. Even though modern weapons surpass them in aspects such as quality, accuracy, rate of fire, ease of use, accessories, and others, they still find their way to the brutal front lines of war.
The T-14 Armata tank. Ever since they rolled inexorably across no man's land in the First World War, tanks have played an integral part in warfare. Seeking to update the aging Cold War designs, Russia has created the next generation of tanks, hoping to bring its armored force into the modern world. While Western nations will continue using upgraded versions of tanks already in use, such as the American M1 Abrams or the German Leopard series, the Russian military is creating a new platform from scratch. The limitations of Russian armor were demonstrated during the Chechen War during the first decade of the century. In that conflict, scores of main battle tanks were lost, especially in the close-quarter fighting of urban environments. In 2011, the Russian military began development of a new main battle tank to replace the outdated T-72, T-80, and T-90 that have been the backbone of their armored force for decades. The process was shrouded in secrecy, only being revealed to Russian military officials in 2013 and unveiled to the public at a military parade in 2015. Manufactured by the Russian defense company Uralvagonzavod, the T-14 has not been produced in significant quantities, with only a handful having been manufactured since the first prototype was unveiled. There are conflicting reports as to the cause of the delays, ranging from technical issues with components to funding cuts to the results of sanctions placed on Russia over its actions in Ukraine. In spite of its limited production run, the T-14 has many innovative features that set it apart from its predecessors. The chassis of the vehicle is modular, being able to be configured as a tank, an infantry fighting vehicle, or as an armored personnel carrier, among other designs. This will make logistics easier, as all of Russia's armored forces would be able to utilize the same spares and replacement parts for a multitude of roles. Such a modular, universal platform is not a new idea, but the concept has fallen out of favor in most countries. Due to the secretive nature of the project, details are limited about the specifications of the T-14, but what information is available gives a good look at the nature of the next generation of Russian tanks. When configured as a main battle tank, the T-14 measures in at 8.7 meters in hull length, not including the main cannon, a width of 3.82 meters and a height of 3.28 meters. It weighs in at 55 tons, making it much heavier than the T-72 or the T-90 it's replacing. The T-14 is divided into three separate sections: the armored crew compartment, the turret, and a space for the engine. The most innovative feature of the tank is the turret, which is unmanned, but is instead remote controlled by the gunner, who is safely ensconced in the armored crew compartment. The main cannon is fed by an auto-loader rather than by hand, cutting back on crew requirements and mitigating potential loss of life. The unmanned turret also takes up less space, giving the tank a lower profile than manned counterparts, increasing survivability. The turret also utilizes an electric traversing mechanism, which is lighter and more reliable than the older hydraulic system for rotating the turret. It can also turn faster, enabling the main cannon to swivel to engage a target more effectively. Unlike most Western main battle tanks, which have a crew of 4, the T-14 is crewed by only 3, a driver/mechanic, a gunner, and a commander, who are seated in the front of the vehicle, shielded from the fuel tank, the ammunition storage, and the engine. This compartment can be accessed by 3 hatches, 2 on top and 1 underneath, the only access into and out of the vehicle. The turret has no external access, limiting entry points for the enemy to take advantage of. The crew compartment, known as a cocoon by the designers, is protected by a composite material and shielded by multiple layers of armor from the rest of the tank, able to keep its occupants alive in spite of significant damage to other sections of the vehicle, including the engine or munitions stored in the turret. This component is also shielded against nuclear, chemical, and biological attacks as well, and it also has an automatic fire suppression system. The hull is protected in a similar way, consisting of a combination of steel and ceramics up to 1400 millimeters thick and able to withstand ATGM projectiles up to 150 millimeters in caliber and APF-SDS up to 120 millimeters in caliber. It's reported that the T-14 can resist a direct hit from an RPG, utilizing reactive armor at the front and sides of the vehicle. Reactive armor consists of an explosive charge sandwiched between ceramic plates which detonate on impact with a shell or missile, diverting or breaking up the projectile. This type of armor is especially effective against anti-armor shape charges. The rear is protected by simple slat armor designed to endure punishment from a myriad of anti-tank weapons. Russian officials also claim that it can withstand a direct hit from American-made Javelin anti-tank missiles, but this is unconfirmed. In order to avoid detection, the T-14 is coated in a radar-deflecting paint, reducing its radar signature. Heat-generating components are buried deep within the hull of the vehicle, reducing its signature on thermal scopes, though modern heat detection devices are sensitive enough to notice even slight variations in heat, limiting this feature's effectiveness. The Armata also reportedly possesses a series of more active defenses. These include the state-of-the-art Afghanit protection system, which can detect incoming projectiles traveling up to Mach 5 in speed. Once detected, the incoming ordnance could either be jammed or misdirected using a soft kill system or outright destroyed by munitions deployed from a hard kill device. The main armament of the T-14 is a 125mm smoothbore cannon, though due to its modular design, this can be switched out in favor of a much larger and more powerful 152mm gun. These can fire both conventional shells as well as state-of-the-art laser-guided munitions, with enough storage space for 45 rounds. The main gun is supplemented by a 12.7mm Cord machine gun and a coaxial 7.62 by 54mm Pechenyek machine gun. There are also some reports that these can be swapped out for a Shipunov 30mm autocannon, though these cannot be confirmed. The crew of the Armata observe the outside world through a series of external wide-angle cameras, which give a 360-degree view of the surrounding battlefield. The cameras are all-weather, being able to use infrared, heat detection, and night vision technology, allowing the T-14 to operate in all visual conditions. The cameras can be zoomed in as necessary to help detect and target adversaries or locate potential threats. Unlike its earlier predecessors, the T-14 is propelled on 7 dual rubber-tired road wheels, as opposed to 6, representing a break with classic Soviet design. It has a reported top speed of 90 kilometers per hour, or 56 miles an hour, and a range of 500 kilometers, or 310 miles on its internal fuel tank, though this range can be extended with an additional external fuel tank. The power plant of the Armata is an 1100 kilowatt diesel double turbocharged engine capable of generating 1200 horsepower, though there are reports that the later variants have a more powerful 1500 horsepower engine. This is coupled with an 8-speed automatic transmission, which is electric, reducing weight. The engine can be revved to over 2,000 horsepower in case of emergency, but this reduces its service life. Not all of the features of the T-14 are as glamorous as armor and weaponry. In order to accommodate the bodily needs of the crew, an internal lavatory is built into each vehicle. This allows the crew to relieve themselves without being forced to leave the protection of the vehicle. This is another way the Armata emphasizes the survivability of the crew, as they can remain shielded inside the tank for longer stretches of time compared to their adversaries. When the Armata project was announced, plans were drawn up to produce 2,300 of the new vehicles by 2025, at a cost of around $4 million each. Instead, due to the complexity of the tank as well as its manufacturing process, only 132 have been delivered by 2020, and a further 20 in 2021. The cost of the Armata is also greater than expected at around $5.7 million per vehicle, much more expensive than previously planned and almost 3 times the cost of an upgraded T-72. This has been the source of controversy within the Russian government, whether to focus on production on the newer but more expensive Armata or continue manufacturing the outdated but significantly cheaper T-72s, T-80s, and T-90s. So far, there have been no indications of the T-14s that have been produced being used in combat. A post on social media by a Russian television presenter has indicated the presence of Armatas in the rear echelon areas in Ukraine. It's been reported that this force would soon be heading toward the Donbas region to support Russian operations there, though this can't be confirmed. Tanks. They've been in use for over a century, from clunky metal boxes trudging between the trenches to the newest main battle tanks, equipped with the latest modern technology. If reports are true, the T-14 Armata potentially represents the next phase in evolution for armored forces. Soviet BTRs. In the late stages of World War II, the Soviets began to practice a doctrine of tank descente. This tactic emphasized the joint action of light infantry with tanks. Since the infantry had no means to follow the rapidly advancing armored troops, soldiers were carried into battle on top of tanks. They would get off the tanks only before the actual fighting took place. Lessons learned in the war helped the Soviets start their own Armored Personnel Carrier, or APC, development program after the war ended. German SDKFZ 251s and American M3 half-tracks were used as a reference for the creation of the first Soviet post-war APCs, the BTR-152 and BTR-40. However, in the mid-1950s, the requirement of modern warfare and the transformation of mechanized divisions into motor rifle divisions called for the creation of new transport vehicles. Thus, a new family of 8-wheeled armored personnel carriers were born, the BTRs. For more than 6 decades, 4 generations of BTRs and thousands of vehicles have been in service and are still roaming the battlefields. BTR-60. The first in the line of BTRs was the model BTR-60. Its design served as a model for all future generations of the vehicle. Later versions had features added or modified, but in essence it was the same type of vehicle. BTR-60 was built in the winter of 1956 under the requirements of the Soviet Ministry of Defense. The Soviet Army leaders were looking for an amphibious 8-wheel, all-wheel drive vehicle with formidable cross-country ability, at least 2 turnable axles and independent suspension. The task was given to several factories, one of them being the famous Gaz, which eventually won the contract. Even though Gaz's design was not the best, they beat their competitors through emphasis of simplicity and affordability. The Soviets needed new armored vehicles as soon as possible and didn't want to risk production halts. After it passed state trials, Gaz's design officially entered service as BTR-60. BTR-60 had a totally different design than all previous armored personnel carriers. It had 8 wheels and was built using welded, sloped armored plates. The driver and commander were positioned at the front, while the troop compartment was behind them. Unusually, the engine compartment was placed at the rear of the vehicle. Surprisingly, the first version of the vehicle, the BTR-60P, had a roofless troop compartment, an essential feature of modern APCs. However, starting from 1963 and the version BTR-60PA, vehicles received armored roofs. With a roof installed, the BTR provided far better protection but reduced the capacity from 16 to 14 men. The drawback of the vehicle was that it had no side doors. Instead, the crew and the troops had to use overhead hatches on the vehicle's roof to exit, which left the vehicle exposed to enemy fire from above. In 1965, the BTR-60PB was introduced, which strove to meet new wartime standards for APCs with the addition of a machine gun turret on top of the roof. With the introduction of a turret, the crew was forced to accommodate a gunner position, which limited the number of soldiers in the compartment area to 8. The BTR-60 was powered by 2 90-horsepower, 67-kilowatt, 6-cylinder gas engines that allowed a maximum speed of 50 miles an hour, or about 80 kilometers an hour on the road. One engine powered the first and third axle, while the other powered the second and the fourth axle. This way, if one of the engines failed, the vehicle could continue running at a reduced speed. Being a fully amphibious vehicle, the BTR-60 could safely move troops across bodies of water. Before entering the water, a rear 2-wing lid opened to reveal a water jet, which could propel the vehicle up to 6.2 miles per hour, or about 10 kilometers an hour. A trim vane was also erected at the front to prevent water from flooding over the bow. The BTR-60 was produced from 1960 to 1976 and saw extensive use in countries such as Afghanistan, Cuba, Egypt, Iran, and Ukraine well into the 21st century. It showed several drawbacks, however, one being the armor thickness ranged from 5mm to 9mm, and as such provided good protection against assault rifles from any distance and machine guns at a more considerable distance. But it was ultimately unsatisfactory to withstand the impact of RPG rounds, which were becoming more common. The engine also suffered from a hot climate. The turret elevation of only 30 degrees was a problem because it didn't allow the gunner to engage the enemy attacking from higher ground. By the beginning of the 1980s, most BTR-60s were replaced with newer generation BTR-70s and BTR-80s. Those that remained were sent to border units and exported to third world countries. BTR-70. In 1971, Gaz engineers began developing the BTR-70, the next generation of armored transporters. To improve combat capabilities, the BTR-70 was designed to overcome the drawbacks of its predecessor. To begin, the internal seat arrangements were modified. A seating bench for 6 soldiers was positioned along the middle of the compartment. Soldiers inside sat back to back, each of them facing side fire ports. 2 more soldiers were sitting on single seats behind the crew with their fire ports facing forward, and the space between the second and third axles was increased to add a small exit hatch. The BTR-70 was also powered by 2 ZMZ 4905 115 horsepower or 85.76 kilowatt gasoline engines. Like its predecessor, the BTR-70 was widely used in Afghanistan, showing the same weaknesses. Most notably, though, this vehicle can still be seen on the battlefields in the war in Donbass and the Russian-Ukraine war. BTR-80. With the BTR-70 showing repeated poor performances in Afghanistan, the Soviets undertook a further evolution of the BTR vehicles, the BTR-80 in 1984. There were 4 main differences between it and the BTR-70, the first being the engine. Instead of twin gasoline engines, the new BTR-80 had a single 260 horsepower or 194 kilowatt turbo V8 diesel engine that called for a new arrangement at the rear of the vehicle. Additionally, because of the engine's position, the water jet box had to be removed. Instead, the BTR-80 had 2 external water jets fitted on the sides of the hull. The third difference was the improved turret. Gaz designers increased the elevation of the turret to 60 degrees. This way, the gunner was allowed to engage an enemy at higher ground and even provide anti-aircraft fire. The new turret also had 6 smoke grenade mortars installed at the rear. Finally, the BTR-80 had 2 side hatches installed to evacuate the soldiers at the troop compartment. The hatch consisted of 2 parts. The upper part was opening forward, providing protection from enemy fire, while the lower part was opening downward to form a ramp. Since 1984, more than 5,000 vehicles have been built. The model is still in the arsenal of the Russian Army and armed forces of former Soviet republics. In 2013, the Russian military industry started the production of a BTR-82A version, equipped with a more powerful 30mm 2A72 automatic gun that can fire armor-piercing tracer APT projectiles, high-explosive fragmentation incendiary HEFI, and high-explosive tracer HET ammunition. The new version was powered by a Kamaz 740 14300 turbo diesel engine, which generates 300 horsepower. For better ballistic protection, BTR-82A's armor was coated with Kevlar laminated synthetic materials. The Russian Army uses both versions in the current war against Ukraine, while the Ukrainian Army only has the earlier version in its armament. BTR-90. The fourth and the last generation of BTRs, the BTR-90 was first introduced in 1994. With a significantly larger hull, this version could accommodate 10 soldiers in the compartment area, 2 more than previous versions. The inner layout is the same as in prior models, with the new turbocharged liquid-cooled multi-fuel diesel engine positioned at the rear. BTR-90 has a whole new turret taken from the BMP-2 infantry fighting vehicle. The turret is armed with a 30mm Shupanov 2A42 gun, a 7.62mm PKT machine gun, and a 9M113 Konkurs anti-tank guided missile launcher. In addition, the turret can be adapted to use a more advanced 9M133 Kornet anti-tank guided missile launcher. Armored protection of the BTR-90 is also improved and can withstand shots from 14.5mm rounds. Furthermore, there is a possibility to increase the protection by adding explosive reactive armor panels. Currently, the BTR-90 is not in the service of the Russian armed forces, and the model is intended for export only, having been overshadowed by the BTR-82.